this is a joint work with Ori Hefetz from Cornell University, also from the Hebrew University. Before beginning, I'll just thank Ned Ogenblick from UC Berkeley for his help in designing the study and initiating it, and for Lev Moreska, who gave great research assistance. So some brief background and motivation. Sorry, I want to move. Okay, now you can see it. Brief motivation, I don't need to elaborate a lot because people talked about it before, but I'm just going to focus on information during that pandemic, which is quite unique in that it's very standardized and numeric information that we're observing all along, which comes in the form of infection counts and death counts in our states or areas, which someone could say would be able to help people estimate what are the chances of being infected with COVID-19, as suggested just a few minutes ago. So this unique feature about COVID-19 with its these information sources make it a relevant case study for the relations between information, beliefs, and also behavior. So we ask in this study to what extent are beliefs about the spread of COVID-19 information-based, and to what extent is behavior based on those beliefs. So the data we're using comes mainly for a survey that we conducted that elicits perceptions about infection and death counts, risk perceptions, and self-reported health behaviors, all of which I'll elaborate on in the next minutes. The survey was run on mTurk between March and August 2020 on a daily basis, covering all US states. It has about 12,000 observations. And we accompany it with administrative data of actual infection and death counts. So let's just see the results. So we begin by looking at how subjects perceive the cumulative population fractions officially confirmed as infected in their state as of the time we're asking them. So all data I'll be showing will be on those two panels, covering our two sources of variation, time variation and state variation. On the left, you can see 10-day moving averages. On the right, you can see within state averages. We view those perceptions in terms of the population fractions they imply in percentages and show them on a log scale, as you can see on the vertical axis. So that's subjects' perceptions, but how do they compare to the official information that they are about? We add this information with the black line and points, the actual information about that cumulative population fraction confirmed as infected, and we find that roughly people's perceptions follow that information, at least on average. There is a systematic underestimation error of about 37%. So that's just the beginning, viewing perceptions about the present. But the most interesting points will come when looking at perceptions about the future. So let's move on to that. We also asked subjects, similarly to what I just described, to predict the cumulative numbers for a month forward, for 30 days from today. And subtracting their estimates for today, we get their predictions for the newly infected population fraction in the next 30 days in their states. And this is shown by the blue line and points. And surprisingly, their predictions, those predictions for the future are also similarly related to official information benchmarks to the way we saw present perceptions are. So let's add this official benchmark with the gray line showing what the actual newly infected population fraction in our subject states was. What are the realized numbers? For example, the value of the gray line in March 1st is what population fraction was newly infected between March 1st and April 1st. Again, we have this systematic underestimation error. This time it's 48% on average. The picture is similar though. So we have this picture about perceptions of COVID cases, but we also elicited risk perceptions about how subjects perceive the likelihood of bad outcomes in their lives and in general. And to have some benchmark relating risk perceptions to perceptions about cases, we have one risk perceptions question that is very tightly related to the question answered by the blue line. And this is the question I'm showing now. What is the average chance of someone from your state to get infected in the next 30 days? If you think about it, the population fraction that is going to get infected should be mathematically identical, or at least very similar to the average chance of someone to get infected, while those empirically are very far off each other. Purple is 72 times larger than blue on average. And this is the finding that we call an inconsistency between our subjects' beliefs, which returns us to our first research question about the relation between information and beliefs. And we can say that that relation depends very much on how you ask and how subjects think about those beliefs. Beliefs about cases are much more information-based in a sense than beliefs about risk. They do much better in those official information benchmarks that we apply. Last thing we're doing is to understand our picture not only relative to information benchmarks, but also relative to behavior benchmarks. That is to understand the relations between those different perceptions and information and beliefs. So we elicited some health protective behaviors in the private domain, such as washing hands more often or sanitizing groceries. And we checked the correlations between the number of behaviors our subjects report that they adopt and those perceptions and the information that we just viewed. And we find that the strongest predictor of behavior is the purple perception, the risk perceptions, while the blue perceptions, the perceptions about cases, are much weaker predictors. This brings us back to the second question. I'm just about to finish that while we find that the beliefs that were more information-based, the blue ones are in fact the ones that are less predictive of behavior and vice versa. So that's an interesting picture that we end up with, implying something that some of you may find intuitive, that maybe just making the public understand information may be successful. The public may have a roughly accurate idea of what's going on in terms of numbers of infections, but it may still be insufficient at affecting behavior, maybe because it does not affect enough behavior-related beliefs, but this is just a speculation. So thank you. Looking forward for the questions.